Now we're going to start talking about inequalities. In part one, though, we're going to solve linear inequalities. Now, you've solved linear inequalities in previous courses, so this will basically be a review. Before we start solving linear inequalities, let's review something about interval notation. So, I'm going to list some intervals, and in these intervals, we're going to express each interval in set builder notation, and then we're going to graph the interval on the number line. All right, so for example number one. So let's suppose we had the interval parentheses 3 to infinity. All right, so when we solve these inequalities, basically what we're saying in this case is that the solutions to this particular inequality would be all numbers greater than 3. Okay, not including 3. Remember, parentheses here with this 3 means that 3 is not a solution. And then so we're going from anything bigger than 3 all the way to infinity. And remember, with infinity and negative infinity, we always include it with a parentheses. All right, so in set builder notation, it would look like this. So your set builder notation, you would basically say this. Notation. You would say the set of x such that, and then looking for all numbers bigger, all real numbers bigger than 3. So we say the set of x is such that x is greater than 3. So that's set builder notation. So remember, x bigger than 3 means 3 to infinity. Since there's no equal sign, we use parentheses. All right, now on the graph, basically what you would do is if this is 0, 1, 2, 3, 4, 5, and so on the graph, since I'm starting at 3, but I can't use 3, 3 is not a solution, and I'm going from 3 to infinity, so any number to the right of 3, I'm going to put parentheses on 3, and then I'm going to shade to the right with an arrow. So that's the graph of this interval, and that's a set builder notation of this interval. All right, so remember, if there's parentheses around the number, with the number, that means that number we cannot use. It's not part of our solution set. So any number bigger than 3, 3.8, 27.6, 40 and a third, any number bigger than 3 will be in this interval. And so any number that's shaded is a solution. All right, so if I had this, let's say I had bracket though, negative 2 to infinity. All right, so the bracket means that I can use, that this is part of the solution set. All right, so that is part of the solution set. So when you wrote this in set builder notation, you said the set of x's such that x is greater than or equal to, the equal sign, remember bracket, negative 2. And then remember, we use the braces for set builder notation. So make sure you use those braces right here. And then the graph then would look like this. So we have 0, negative 1, negative 2. And in this course, we use parentheses and brackets. We don't use circles or open circles or closed circles. Make sure you're using parentheses and brackets. Let's see. All right, so we're going to go bracket at negative 2, since negative 2 is a solution, since negative 2 is included in this interval, all the way to infinity with an arrow. And so, and remember, with infinity and negative infinity, we always use parentheses. So for example, if we had this, negative infinity to, let's say, 6 with a bracket. Now this time the set builder notation would look like this. You'd say the set of x's such that x is less than or equal to 6. That's what this says. So you want all numbers less than 6. So you're going negative infinity. So in your mind, when you look at this, when you look at the graph, if this is 0, And let's say this is 6. All right. So if this is 6 right here, then you're going from, okay, bracket 6, bracket at 6. Make sure you, at 6, that's where you draw the bracket. So make sure you understand that at -2, that's where the bracket is. At 3, that's where the bracket is. Don't put it anywhere else but on 3. Okay, so, and so you're going to the left with an arrow. So that's what this is. Okay? And then 4, let's suppose we had bracket -4 to, I'm sorry, parentheses -4 to 2 with a bracket. All right, so this, in this case, now this is how you would write the set builder notation. You say the set of x's such that, now remember your solutions would be any number between -4 and 2, including 2, but not including -4. There's parentheses or -4, so I don't use it. That's not, -4 is not a solution, but 2 is because there's a bracket. So remember your numbers are between these two. So notice I said between. So here's how it's going to look. You're going to say such that the set of x is such that x is between, that's how it looks, -4 and 2, but since there's a bracket at 2, I need to put less than or equal to. So that's how it looks. So the set of x's such that your solutions are between -4 and 2. Since I can't use -4, since there's a parentheses, there's no equal sign, it's strictly, x is strictly going to be greater than -4, and then here x is going to be less than or equal to 2. So I cannot use -4, but I can use 2. So my solutions do not include -4, but they do include 2. So on the graph, notice when you had infinity and negative infinity, you had those little arrows. You had arrows. Here, there are no arrows because notice you're going from -4 to 2. So -4, you have parentheses, 2, you have bracket, and you're shading and everything between them. All right, so that was a quick review in terms of set builder notation and graphing these. So we're going to use these ideas when we start solving these linear inequalities. Okay, so again, as I said, the solving the linear inequalities in this section is a review from a previous course. So let's look at this example. So we're going to solve each inequality. To solve each inequality. All right, number 1. We have 5x plus 11 is less than 26. So 5x plus 11 is less than 26. So remember, this is not an equation, but you're going to solve it like it were an equation. The same properties apply. The same properties of equality would apply here. So I'm going to add a -11 to both sides, and then I'm going to divide both sides by 5. So the properties still apply. Except here, when you're dealing with inequalities, there's a good chance you're going to have an infinite number of solutions. So if you go back over here, see anything that's shaded is a solution. So there's an infinite number of solutions. So you have all these irrational numbers and rational numbers. Any real number is a solution. The square root of 72 is a solution. The real number 4 1/3 is a solution. So any real number is a solution. So again, you have an infinite number of solutions here. You have an infinite number of solutions. You still have an infinite number of solutions here. Even though it's bounded between -4 and 2, there's an infinite number of real numbers that are in here. There's no way you can count them all. For example, 1.88889999 and so on is a solution. 1.9904328 and so on is a solution. So there's an infinite number of solutions. So you can't list them, so that's why we graph them. That's why we put them in set builder notation. That's why we put them in interval notation, because you can't list them. There's not a finite number. Now, there are going to be situations where there are going to be no solution. But in almost all cases, when you have an inequality, you're going to have an infinite number of solutions, so you're going to graph those. So here we're going to solve this inequality. So I want to find out what numbers can I plug into x, what numbers I can plug into x, so that when I multiply by 5 and add 11, it's still less than 26. All right, so again, there's going to be an infinite number of solutions. All right, so just if this was the equation, I would subtract 11 from both sides, combine like terms. I get 5x is less than, and that's going to be 15. And then to get x by itself, I'm going to divide both sides by 5. And so my solutions would be any number that's less than 3. That's my solution. So any number less than 3 makes this original inequality true. I mean, you can check this. Let's say 2. 2 is less than 3. Let's see if 2 works. 5 times 2 is 10. 10 plus 11 is 21. And 21 is less than 26. Let's check. I'm going to use integers. I'm not going to use decimals. But any decimal would work as long as it's less than 3. Let's say 0. 5 times 0 is 0. 0 plus 11 is 11. 11 is less than 26. Let's say negative 3. 5 times negative 3 is a negative 15. A negative 15 plus 11 is a negative 4. And a negative 4 is less than 26. So you see, there's an infinite number of solutions. All right, now, they're going to ask you to write this in interval notation. So interval notation. And they're going to ask you to graph this. All right. So sometimes it helps if you do the graph first. So watch. If I do the graph first, here's 0, here's 1, here's 2, here's 3. Again, I want all numbers that are less than 3. There's no equal sign, so I cannot use 3. And remember, less than, so you're going all the way to the left. All the way to the left. So when I go to the left, I'm going to put parentheses here on 3, and then we go to the left. So there's my graph. Now from the graph, I can write the interval notation. So remember, this arrow is pointing towards negative infinity. So, and remember, when you write something in interval notation, you always go from smallest to largest. So you go from left to right. You go from smallest to largest. So I'm going to negative infinity, parentheses. Remember, with infinity to negative infinity, you always use parentheses. Negative infinity, comma, all the way to 3. And so since there's no equal sign, we're going to use parentheses. And so there's my interval notation. All right, number 2. Suppose we had negative 9x is greater or equal to 36. Okay, so now we're at a situation, you may recall this, we're at a situation where to get x by itself here, I'm going to have to divide both sides by negative 9. So remember, there's a property in the previous course that we saw that whenever we divide or multiply an inequality by a negative number, so whenever we multiply or divide an inequality by a negative number, a negative number, we must reverse the inequality symbol. All right, so to get the variable x by itself, I'm going to go ahead and divide both sides by negative 9. Just like this. Now what I do to one side, I do to the other. All right, now remember, we tend to circle this. Remember why we circled this in the past. We circled this to remind ourselves that I got to reverse this because I'm dividing by a negative number. Here, I divided by a positive number, so I didn't have to reverse it. It stayed less than. Here, I'm dividing by a negative number. So I have to reverse this. So negative 9 divided by negative 9 is 1. 1 times x is x. But my solution will be not greater than or equal to, but less than or equal to. And then a positive divided by negative is a negative. 36 divided by negative 9 is a negative 4. So your solutions are any number less than or equal to negative 4. So remember, whenever you divide or multiply an inequality by a negative number, you got to reverse the inequality symbol. So your graph would look like this. So here's 0, negative 1, negative 2, negative 3, negative 4. And it's less than or equal to, so that means that negative 4 is a solution. Now make sure you understand why negative 4 is a solution. Negative 9 times a negative 4 is a positive 36. And 36 is bigger than or equal to 36. It's equal to it. Now let's see why 0, so when I shade this, watch, when I shade this, bracket negative 4, Notice 0, none of these numbers here are shaded, so they're not solutions. So let's see why 0 is not a solution. Negative 9 times 0 is 0, and 0 is not bigger than or equal to 36. So that's why it's not shaded. But negative 5 is, so let's check negative 5. Negative 9 times a negative 5, a negative times a negative is a positive. So negative 9 times a negative 5 is a positive 45, and 45 is bigger than or equal to 36. All right, so we found all the solutions. So any number less than or equal to negative 4 is a solution. Now, interval notation, remember you go from left to right, so from smallest to largest. So you're gonna say negative infinity with parentheses, because remember infinity, negative infinity, always use parentheses, comma, all the way to negative 4 with a bracket because I can include negative 4. All right, let's look at this one. Okay, suppose I had x plus 1 is greater than 2x minus 5. So let's say we had this. Okay, so there are a couple ways to do this. So notice in the previous two, what many students like to do is they like to have the variables on the left side, and that's fine. It does not matter. So notice x is less than 3. X is less than or equal to negative 4. So the variable's on the left, it's easy to graph. Now here's the situation. Let's suppose, you see this 2x here and this x? So since 2 is bigger than this 1, some students will tend to bring the variables to the right and the constants to the left. So let's see what happens if we do this. So I'm going to go ahead and subtract x from both sides. And so I get x subtract x is 0. 0 plus 1 is 1. So I get 1 is greater than 2x minus x is x minus 5. Then adding 5 to both sides, I get 1 plus 5 is 6 is greater than or equal to x. And negative 5 and 5 is 0. So I solve for x. X is by itself. Now here's where you got to be careful. See, some students, it's right here, the less than, remember we said we go to the left, less than or equal to, we go to the left. But the reason we do that is because x is on the left side. So this says that any number less than 3 is a solution. So any number less than 3 is a solution. Any number less than negative 4 is a solution. But here, be careful. This doesn't say x is greater than 6. This says 6 is greater than x. That's what that says. So 6 is bigger than any of my solutions. All right, so that's what that means. So basically on the graph, if this is 6, then that means that 6 is the largest that I can use. I can't go anywhere beyond 6. Now that is a little confusing. So what you may want to do is this. Write it backwards. It makes it easier. So if 6 is greater than x, then that means x is less than 6. That's what that means. So these two are equivalent. They mean the same thing. So x is greater than 6 means x is less than 6. All right, so now from here we have parentheses on 6 going to the left. And now I can do the same problem. Instead of bringing the variables to the right, you could have brought them to the left. So let's see what happens if you do that, if you bring the variable to the left. So we're going to do 3 again with a little star. So still the same problem. So x plus 1 is greater than 2x minus 5. Except this time subtract 2x from both sides. Combine like terms, x minus 2x, that's a negative x, plus 1 is greater than negative 2x, and a 2x is 0, and 0 and a negative 5 is a negative 5. Subtracting 1 from both sides, and combine like terms, positive 1 and negative 1 is 0, negative x plus 0 is negative x, and it's greater than negative 6. All right, so that's where I'm at. Now remember, you're trying to get x by itself, not negative x, but x. So what you may want to do is, remember this number here is understood to be a negative 1. So rewrite it as negative 1 times x if you have to do that. And then to get x by itself, right now multiplying by negative 1, the opposite is to divide by negative 1. And remember, I'm dividing by negative number, So whenever you multiply or divide an inequality by negative number, you have to reverse the inequality symbol. So you got to reverse this. And so therefore, negative 1 divided by negative 1 is 1. 1 times x is x. So x is greater than 6. All right, so I think right here, I'm sorry, x is less than 6, sorry. So I got to reverse this. So greater than, less than. So x is less than 6. All right, so the graph, then here's 6, here's parentheses and 6 going to the left. So that's less than. So notice you get the same answer. You get the same answer regardless of whether you bring them to the right or the left. You just have to be careful in both approaches. All right, number 4. All right, let's suppose we had 8x minus 11 is less than or equal to 3x minus 13. So 8x minus 11 is less than or equal to 3x minus 13. So I'm going to bring the variables to the left. So I'm going to subtract 3x from both sides. And so 8x minus 3x combine like terms. So notice I have this linear inequality. So it's easy to solve a linear inequality. So I'm going to subtract 3x, combine like terms. 8x minus 3x is 5x minus 11 is less than or equal to. That's 0, and 0 to negative 13 is a negative 13. Adding 11 to both sides, I get, and I combine like terms, I get 5x is less than or equal to. Negative 13 and a positive 11 is a negative 2. Dividing both sides by 5, and then reducing the 5s here, simplifying, I get 1 times x is x is less than or equal to negative 2/5. All right, so on the graph, now you're going to have to estimate where negative 2/5 is. So this is 0, and this is negative 1. The negative 2/5 is about here. So estimate where that is. All right, and then it's going to be less than or equal to, so it'll be a bracket here, so that's where negative 2/5 is approximately located, and you're going to go to the left. Now in terms of interval notation, it'll be negative infinity to negative 2/5 with a bracket. And here, that would be negative infinity to 6 with a bracket. Oops, sorry, parentheses. All right. Just make sure that when you draw your brackets and parentheses, it actually looks like parentheses. It actually looks like a bracket. All right, number 5. All right, suppose we had 1, well, let's do this. 2 times x plus 4 is less than, let's do greater than x plus 3, let's say. So 2 times x plus 4 is greater than x plus 3. All right, so to get rid of the parentheses, you're going to use the distributive property. So remember all these that you did, all this is a review from previous course. So you want to solve this linear inequality, so you're going to use the distributive property. So that's an equation, that's what you would do. You would get rid of the parentheses by using the distributive property. 2 times x is 2x, 2 times 4 is 8, is greater than x plus 3. So to bring the variables to one side, constants to the other, so I'm going to subtract x from both sides. What you do to one side, you do to the other. 2x minus x is x, plus 8 is greater than x minus x is 0, plus 3 is 3. Subtract 8 from both sides. 8 subtract 8 is 0. X plus 0 is x, is greater than, and then 3 to negative 8 is a negative 5. So my solutions are any number bigger than negative 5, but not including negative 5. So your graph, if this is negative 5, you put parentheses on negative 5, but going to the right this time, because your solutions are any number bigger than negative 5. Your interval notation, remember you always go from left to right, from smallest to largest. Negative 5, even though negative 5 is not included, we're going to go all the way down to negative 5, so that's going to be the smallest, and then you're going to go to infinity. So your interval notation then would be parentheses, -5, since there's no equal sign, this is parentheses, all the way to infinity with parentheses. Okay, number 6, you have 2x minus 11 is less than, let's do greater than, is greater than or equal to, -3 times x plus 2. So 2x minus 11 is greater than or equal to -3 times x plus 2. Okay, so again, if this was an equation, a linear equation, you would get rid of the parentheses, use distributive property, just like in the previous lesson, previous example. So I get 2x minus 11 is greater than or equal to, and then that would be -3x minus 6. All right, let's bring the variables to the left. So I'm going to add, so right now this is a -3x, so I'm going to add 3x to both sides. What you do to one side, you do to the other. 2x plus 3x is 5x minus 11. So all I did was combine like terms. Is greater than or equal to. -3x and the positive 3x is 0. Now 0 and a -6 and -6. So they'll make the mistake of just putting 6. It's a -6. Now adding 11 to both sides, I get, and combine like terms, this is 0. So I get 5x is greater than or equal to. And then 6 and a positive 11 is 5. And then the next step is to divide both sides by 5. 5 divided by 5 is 1. 1 times x is x. Is greater than or equal to 1. So my solutions would be any number that's bigger than or equal to 1. So my graph, if this is 0 and this is 1, so it'll be a bracket going to the right. So you shade in everything to the right with an arrow. And so your interval notation then would be, remember we always go from smallest to largest. So it'll be bracket 1, comma, to infinity with parentheses. All right, number 7. All right, suppose you had x divided by 4. So this time we're going to have some fractions. So let's see if you remember how to deal with fractions. X divided by 4 minus 3 halves is less than or equal to x divided by 2 plus 1. So x divided by 4 minus 3 halves is less than or equal to x divided by 2 plus 1. Okay, so remember, we got to clear the fractions. So there are no parentheses, so I don't have to use the distributive property just yet, but I do need to clear the fractions. So to clear the fractions, I'm going to multiply both sides by the LCD. So the LCD here, 4, 2, 2, and remember this is 1 over 1. So 4, 2, 2, and this 1 that's in the denominator, the LCD is 4. So I'm going to multiply both sides by 4. And remember what we did, since this is 2 fractions and this is 2 fractions, I'm going to enclose that in parentheses on both sides. Right, just like this. Because you're going to multiply both of these, both sides, by the LCD so you can clear your fractions. So you multiply both sides by 4, just like that. And then you're going to use the distributive property. So you're going to distribute the 4. Distribute the 4. Now don't make mistake of reducing these 4s for like you have them here before you distribute. Because if you do that, you'll say 4 to 4 is 1, 4 to 4 is 1, and then you'll distribute the 1. But this 2, this 3 halves, has to be multiplied by 4 as well. So you got to be careful. So before you reduce, you need to distribute. So you need to actually do this next step. You need to say 4 times x divided by 4 minus 4 times 3 divided by 2 is less than or equal to 4 times x divided by 2 plus 4 times 1. So every term, all these 4 terms here has to be multiplied by 4. Notice they're being multiplied by 4. And so then you reduce. So you say 4 into 4 is 1, 4 into 4 is 1, and so that's 1 times x is x. Over here, minus, so you're subtracting. 2 into 2 is 1, 2 into 4 is 2, but 2 times 3 is 6. It's less than or equal to. 2 into 2 is 1, 2 into 4 is 2, 2 times x is 2x, plus, and then 4 times 1 is 4. All right. Now, you can bring the variables to the left, constant to the other. It does not matter if you bring them to the right. You bring it to the right. Notice you have the variable on this side, so you got to be careful how you rewrite it. If you bring the 2x to the left, you're gonna have to at some point divide by negative numbers, so you have to reverse the equality symbol. So I'm going to go ahead and just bring them to the right, just so you can see how to rewrite it. So I'm going to subtract x from both sides. And so x subtract x is 0. 0 to negative 6 is a negative 6. It's less than or equal to 2x minus x is x plus 4. And then bringing the 4, bring the constants to the left. I'm going to go ahead and subtract 4. A negative 6 and a negative 4 is a negative 10. And negative 10 is less than or equal to x. So what that means is that negative 10 is going to be the smallest of all your solutions. So you may need to rewrite it backwards. So rewrite this. Rewrite this, because if you're not careful, you're going to see this less than and you're going to shade to the left, and that's incorrect. You don't shade to the left. Because what this says is, when you rewrite it, this says that all my solutions are bigger than or equal to a negative 10. That's what that says. So this says that negative 10 is the smallest, is less than or equal to any of your solutions. Negative 10 is less than or equal to all of your solutions, so that means it's the smallest, which means that x is greater than or equal to negative 10. That's what that means. And so if you have negative 10 here with a bracket and you shade to the right, and so your interval notation then would be bracket negative 10 comma infinity. Okay, so we're going to do some, I'm going to do a few more problems in the next video. We're already at 32 minutes. So basically in this section, the next lesson we'll do some with fractions. Okay, so basically part 1, and I'm going to go ahead and call this part 1A. So part 1A. So part 1A, we solved linear inequalities. So we talked about how to write intervals in set builder notation, what the graph looks like. Then we started solving simple linear inequalities. These are all linear inequalities. And we saw that whenever we multiply, divide a negative number, an inequality, by a negative number, we have to reverse the inequality symbol. So greater than equal to becomes less than equal to. Less than becomes greater than, and so on. All right, and then we saw that there might be situations where the variable would appear on the right side, so you have to rewrite it. And then we did one problem with a fraction. So remember, when you have fractions in equations or inequalities, you want to clear your fractions, so you have to find the LCD. All right, and then you just do the process. Okay, so that takes care of 1A.